Okay, fams, this is the second question we're given as a take home on projectile. A hose lying on the ground shoots a stream of water upward at an angle of 40 degrees to the horizontal. The speed of water is 20 meters per second as it leaves the hose. How high up will it strike a wall 8 meter away, and with what speed will it strike? Now, this question is very simple and direct. Well, first of all, let's try to see if you can get a pictorial interpretation of this very question. Now, a hose, there's a wall like this. You have a wall this way, standing like this, you have a wall. So, while on the ground, we have a hose, probably shooting out water. You have a hose. So, this hose shoots water out outward. Look at, let's say a hose shoots a stream of water upward at an angle of 40 degrees to the horizontal. The speed of the water is 20 meters per second. So this what happens. The water leaves with this speed, 20 meters per second. Now at an angle of what? 40 degrees to the horizontal. 40 degrees to the horizontal. So it's very direct. Now, don't forget that this everything happening from this place, from this hole, as a host shoots out water. Now it's shooting it onto a wall that is how many meters away? The wall, according to the question, the wall is 8 meters away. There's a wall here. A wall just happens. There's a wall here. While a hose shooting out some water from this angle of 40 degrees to the horizontal, the water keeps pumping out. So the question is, how high up this wall will the water hit? According to the question, look at it. How high up will it strike a wall 8 meters away? So it's very simple. So the best thing we're going to use, we're going to be using the trajectory formula. Don't forget that we have to distances simultaneously. We have distance along the x-axis and also the distance we want us to look for, the distance along the y-axis. How high up the wall? So don't forget a very popular formula. So distance along the y-axis is distance along the x-axis tan theta, then plus 1 over 2 gravity, then distance along the x-axis squared over initial speed squared cos squared theta. That's what we have. That's what we're using again. We're going to be using this trajectory formula. Don't forget that this formula is merely applicable when we talk about distance both along the x-axis and y-axis simultaneously. We're not talking about range. There's not really range. We're not talking about mass height. We're talking about two distances at the same time. So now don't forget. First of all, we have distance along the y-axis, along the x-axis. I beg your pardon. It's already given. It's 8 meters. So we have the angle theta 40 word, 40 degrees. So we're asked to get how high up the distance along the y-axis. That's what we're asked to get. So the initial speed of the water is given. Initial speed, the water is being shot. The speed of water is 20 meters per second. Initial speed is just 20 meters per second. So now you're going to fix all these parameters into this very formula. As simple as that. So distance along the y-axis, how high up will it strike the wall? So distance along the x-axis is 8 meters times tan theta. Tan of the angle is 40 degrees. And then plus 1 over 2 gravity. And don't forget that this body was being shot up, so it disobeyed gravity. So gravity is going to be minus 10 meters per second squared. That's minus 10. So distance along the x-axis, which is 8 raised to power 2 over initial speed. Initial speed is, what do we have there? Is 20 raised to power 2 times cos, also angle, cos 40 raised to power 2 also. So what do we have? Distance along the y-axis, which is what we are looking for. So 8 times 30, we're going to be using our calculator to help us quickly solve this. So 8 times tan 40, let's see what we have. 8 times tan 40, that'll give us 6.712. Let's say 6.71. 8 times tan 40 is 6.7. Let's say 6.7. 2 year 1, 2 year 5. Plus is minus, minus 5. Open the bracket, 8 raised by 2 is 64 over. Now let's see what we have down there. 20 raised by 2, which is 400. 400 times cos 40 raised by 2. Let's just do that directly to save our time. So 20 raised by 2 is 400 times cos 40. 400 times cos 40. 400 times cos 40 raised to the power of 2. So what do we have? We have 400 times cos 40 raised by 2. So that will give us That'll give us 243.72. That's 243.73 approximately. So the next three is that you're going to times this, 5 times this over this. So that's going to be 5 times 64 divided by the answer we got. That'll give us 1.36. So the distance along y-axis is 6.7 minus 1.36. So the distance along the y-axis, 6.7 minus 1.36, you know what that will give to us? That will give us 5.34 meter. So it means as a host shoots out some water. Now the water is going to hit the wall 5.34 meter high up the wall. So it's very simple. The host shoots out some water at an angle of 40 degrees with the horizontal. Now the water keeps going at an angle of 40 degrees with a speed of 20 meters per second, while the wall 8 meters away will be hit as high as 5.34 meter. So it's very, very simple. So that's that for the very first one. So also we are asked to get the speed with which it's going to hit the wall. That's the next question. What speed is it going to use to hit the wall? What speed will it hit the wall with? Let's say the speed is going to hit the wall with. That's another one. That's landing velocity. That's what we're talking about. The second question is landing velocity. So what speed will it hit the wall with? What speed will it hit the wall with? Now, simple. Don't forget, you're going to get a resolution. Now, initial speed is 20 meters per second. So if initial speed is 20 meters per second, the initial speed along the x-axis is 20 times sine 40 degrees. Don't forget we worked on that already. The initial speed along the y-axis is 20 times cos 40. So initial speed along the x-axis, that will be 20. That's 20 times, what do we have there? 20 times sine 40. That's 12.85. That's 12.86 meter per second. So initial speed along the y-axis, that will give us that's 20 times cos 40. That will give us 15.32 meter per second. Now don't forget, now the fact that the water did not flow on the floor. The water, everything here mainly is virtually in the air. Although we have a distance covered on the x-axis, there is no acceleration along the x-axis. That is known already. What does that mean? It means the initial speed along the x-axis is the same as the final speed along the x-axis. So if this is what we have, initial speed along the x-axis, this initial speed along the y, this initial speed along the x, 20 meters per second at 40 degrees. Opposite hypotenuse adjacent. So opposite of hypotenuse is sine, adjacent of hypotenuse is cos. So initial speed along the y-axis is this, initial speed along the x-axis is this. So if this is initial speed along the x-axis, it's going to be the same thing with the final speed along the x-axis. Why? Because there is no movement, acceleration of the water on the x-axis on the ground. But we're going to be having a varying final velocity along the y-axis. So we're going to be looking for that. The final velocity along the y-axis is what we are looking for. So don't forget, we know acceleration. Acceleration along the y-axis is minus 10 meters per second squared. We know that the body was moving against gravity. That is well known. So we know that is clear to us. That is clear to us. So since acceleration along the x-axis, along the y-axis is minus 10, so we have this. So what we're looking for the final velocity along the y-axis. We're looking for the final velocity along the y-axis. Don't forget, we know the distance already. The distance the body covers, the distance it covers, it heats is 5.34 meter. So the distance is 5.34 meter along the y-axis. Final initial acceleration. So it's very simple. We have everything well set out. So now we're going to be using v squared equal to u squared plus 2as all along the y-axis. All along the y-axis. So what do we do next? The next thing we're going to do, we're going to fix in all this. So v squared is equal to initial speed along the y-axis is 12.86 raised to the power 2 plus 2 times acceleration along the y-axis minus 10. Then the distance covered is 5.34. So v squared is equal to, so let's use our calculator. Our calculator will help us solve this. So 12.86 raised to the power 2 is 165.37. 379. So 165.38. Then this plus and minus. So 2 times, so let's see, 2 times 10 times 5.34. That will give us 106.8. 106.8. So what do we have? Distance. So 165.38 minus 106.8. So 165.38 minus 106.8. So what do we have? We have 58.58. 58.58. So the final distance along the y-axis will be the square root of this result. Square root of our answer, that's 7.65. 7.65 meter per second. So the initial speed is 12.86 meter per second square, meter per second, I beg your pardon. Then the final speed is 7.65 meter per second. But for everything along the x-axis, the initial speed and the final speed are both 15.32. So it means while the wall stands here like this, and water has been shot from the hose, so it means two things. It means the final speed, let's see that already. The water hits the wall with this final speed along x-axis, and also hits the wall. It hits the wall with the final speed along the x-axis, and also hits the wall with this final speed along the y-axis. So what do we have? Final speed along the x-axis is what? Is 15.32 meter per second. So final speed along the y-axis is 7.65 meter per second. So we just do this. We're going to do this. We're going to be using Pythagoras theorem. We have the angle of landing theta. So this is what we are looking for. We are looking for the speed it will hit the wall with. It hits the wall with two kinds of speed. Speed along the x, 15.32. Speed along the y, 7.65. So the resultant speed now is what we are looking for. Resultant speed. So that's going to be r squared, 15.32 raised to power 2 plus 7.65 raised to power 2. So r squared is, so we're going to be using our calculator to solve this up. 15.32 raised to power 2 plus 7.65 raised to power 2. You have 293.2249. 293.2249. So 293.22, or let's say 0.2 actually. So square root of our answer, is what we're going to get the square root of the result, 17.1. So it's going to hit the wall with a resultant speed of 17.1 meter per second. We can also get the angle of hitting the wall. Can also get that. So this is as simple as ABC. So this is everything for the second question. Quite complex, but very interesting. So watch out for the third questions and solutions.